Hello people, so in this video we're going to talk about factorizing algebraic expressions. We are going to discuss three cases. The first one is factorizing by grouping. This is when you have four terms most of the time, or six, or something like that. When there is no common factor for all the four terms, what to do is you group them into ones that have common factors and then you factorize by group. So we have xy plus 4x plus 3y plus 12. And if you look at these two first terms, x, y, and 4x, they have x as their common factors. And take note, factors are numbers that multiply together to give an answer. So if you look at xy is a term which came from x times y. So x and y are factors of xy. Just like 4 times x gives 4x, 4 and x are factors of 4x. So if you look at these two, their common factors are x. So put the common factor outside, and we put the other uncommon factors inside the bracket. Where you can find the other factors by going like this. X times y gives xy, and x times positive 4 gives positive 4x. Or you can find the other factors by dividing xy divided by x leaves y. Y is the other factor for xy. And 4x divided by x gives positive 4, which is the other factor for 4x. Now we look at these other two terms, positive 3y and 12. So if you look at 3 and 12, they have a common factor of 3. Factors of 3 are 1 and 3. Factors of 12 are 1 times 12, 1 and 12. 2 times 6, 2 and 6, 3 times 4, 3 and 4. So the highest common factor for 3 and 12 is 3. We put it outside the bracket and we find the other factors. We can guess like this. 3 times what will give you 3y? So 3 times y gives 3y. Or we can divide 3y divided by 3 gives y. And 12 divided by 3 gives positive 4. After we group and factorize, we combine the factors together. So y plus 4 is the common factor for both groups, y plus 4. And the other factor is x plus 3. So another case is when all the terms have a common factor. This mostly happens when you have 2 or 3 terms. Sometimes you may have 4 terms or more. Now, when all of them have a common factor, you can just pull out the common factor, put it outside the bracket, and then the other factors go in the bracket. The common one stays outside. The other uncommon ones go in the bracket. So negative 5 and negative 20, they have a common factor of negative 5. So it goes outside. Then negative 5x divided by negative 5 gives an x. Or negative 5 times x gives negative 5x. Negative 20 divided by negative 5 gives a positive 4. Or negative 5 times positive 4 gives negative 20. Now the last case in this video is factorizing difference of two squares or difference of perfect squares. The answer you get will be a conjugate pair. So we have x squared minus 16, x squared minus, 16 here. We write it in terms of 4 to the power of 2 to make it look clearly like a perfect square. And once we do that, we can now ignore the power of 2's, and the factors will be made up of x and 4 in a conjugate manner. So one factor will be x plus 4 and the other factor is x minus 4. Take note, in the previous video we were expanding conjugate pairs, which gave us the difference of perfect squares as the expanded answer. So now when we want to factorizing is the opposite or the reverse process of expanding. So if you want to proof check your answer, you can go and expand the brackets again. Let's see. X times x will give you an x squared, x plus 4 times x minus 4. If we expand again, x times 6 gives x squared, x times negative 4 gives negative 4x, 4 times 6 gives positive 4x, and 4 times negative 4 gives negative 16. Collecting like terms here, negative 4x plus 4x gives 0, and we are left with x squared minus 16. X squared is a square number, 16 is also a square number, so this is a difference of perfect squares. So when we factorize it, we are going to get conjugate pairs like this. The other example, 9a squared minus 4b squared. 9 is a square number, and it's easily seen when you write it in its square form. 9 is 3 squared. A squared is a squared. 4 is 2 squared, and b squared is b squared. Now you can pull out the bases, leave out the powers, pull out the bases 3a and 2b, and when we when we factorize difference of perfect squares, our factors will be a conjugate pair. So we take the bases and we make conjugate pairs out of them. So that's a 3a plus 2b times 3a minus 2b. And again, you can expand, reverse the process to proof check your answer. So we have 3a plus 2b times 3a minus 2b. And as we learned earlier, when you have a conjugate pair multiplying, you can get a difference of 2 squares as the answer. Or going the normal way, following the distributive law, 3a times 3a gives 9. 3 times 3 is 9. A times a is a squared. 3a times negative 2b is negative 6. 3 times negative 2 is negative 6. A times b is ab. 2b times 3a is a positive 6ab. And 2b times negative 2b is negative 4b squared. Collecting like terms here, we have 9a squared. Negative 6ab plus 6ab is 0. And we are left with 9a squared minus 4b squared. 9 is a square number, a squared is squared. 4 is a square number, b squared is a square number. And this is a difference of perfect squares. This proves when you factorize difference of perfect squares, you will get conjugate pair factors like this. Don't forget to subscribe and like the video and press the bell icon to get notified for any videos that are uploaded. See you in the next one.